We need to start this story with a harsh truth. For the last 15 years, the automotive industry has been lying to you. They have sold you the dream of the software-defined vehicle. They have put massive touchscreens on the dashboards of Mercedes, Audis, and Fords. They have added voice assistants that don't understand your accent and navigation systems that get lost in car parks. But if you strip away the leather, the ambient lighting, and the marketing budgets, you are left with a terrifying reality. The brain of the modern car is dead. It is archaic. It is a relic of a bygone era. While our mobile phones and our laptops were evolving at the speed of light, automotive chips remained frozen in time. The industry became addicted to mediocrity. They relied on generic suppliers. They relied on the "we're good enough" philosophy. But as we pushed for autonomy, as we demanded that cars drive themselves, this house of cards began to collapse. We added LiDAR sensors that generate millions of data points per second. We added 4K cameras that see every crack in the pavement. We added ultrasonic radars. And then, we fed this tsunami of data into a chip that was designed to play video games. The result is a nervous breakdown. The car isn't thinking. It is panicking. It is shedding data just to stay alive. The latency, that critical gap between seeing a child on the road and applying the brakes, has hit a wall. We reached the limits of silicon. Or so we thought, because while the giants of Germany and Detroit were sleeping, a laboratory in Guangzhou was building a new kind of predator. Let's talk about the XPeng Turing. And let's be clear, this is not just another chip. This is not an iterative update like the iPhone 15 replacing the iPhone 14. This is a biological leap. To understand why, you have to look at the architecture. Most automotive chips are general purpose. They are the jack of all trades. They try to run your infotainment system, your air conditioning, and your self-driving algorithms all at once. They are distracted. The Turing is different. It is a specialist. It is a sociopath designed for one purpose: artificial intelligence. Inside this piece of silicon, XPeng has engineered a custom 40-core processor. But the magic isn't in the cores. It is in the Neural Processing Unit, NPU. XPeng stripped away the fat. They removed the legacy code support. They removed the graphics rendering pipelines that weren't needed. They dedicated every square nanometer of the silicon wafer to matrix multiplication, the fundamental mathematics of deep learning. This allows the chip to punch significantly above its weight class. It runs cooler. It runs faster. It consumes less energy while processing more data than any chip in history. It is the first time a car company has stopped renting a brain from a supplier and decided to grow its own. Now, we must address the number that has sent shockwaves through the boardrooms of Silicon Valley: 2,250. In the world of high-performance computing, we measure power in TOPS, trillions of operations per second. To give you a sense of scale, the computer guiding a Tomahawk cruise missile runs on a fraction of a single TOP. A Tesla Hardware 3 computer runs at 144 TOPS. The Nvidia Orin X, the chip that every luxury brand covets, runs at 254 TOPS. XPeng looked at these numbers and decided they were pathetic. In their new flagship architecture, which will power the P7 Plus and the G7 Ultra, they are not using one chip. They are stacking 3 Turing processors in a parallel array. The combined output is a staggering 2,050 TOPS. Why do you need this level of violence? Why do you need a supercomputer in the boot of a sedan? The answer is computational abundance. When you have 2,250 TOPS, you don't have to compromise. You don't have to choose between tracking the cyclist or tracking the lorry. You track both. You track the bird flying overhead. You track the pothole. You track the reflection in the shop window. You process the raw, uncompressed feed from every sensor simultaneously. This allows the car to build a world model that is more detailed, more accurate, and faster than the human brain. It is the end of latency. This is the chapter where the old world dies. For decades, robotic driving was based on if-then logic. Programmers sat in cubicles and wrote millions of lines of code. One if red light, stop. If green light, go. If obstacle, brake. This works in a laboratory. It fails in the real world. The real world is chaotic. It doesn't follow rules. The Turing chip was designed to kill if-then logic. It is engineered to run large models, AI brains with 30 billion parameters, locally. This is the automotive equivalent of carrying ChatGPT in your pocket. But instead of writing essays, it drives a 2-ton weapon. This AI doesn't follow rules. It uses intuition. Imagine a ball rolling into the street. A rule-based car sees a sphere vector and brakes because of an obstacle. The Turing AI sees the ball, understands the concept of play, infers that a child is likely chasing it, scans the pavement for movement, and prepares to stop even before the child appears. It understands causality. It understands human behavior. It understands aggressive drivers, confused tourists, and erratic cyclists, not as mathematical variables, but as agents with intent. This semantic understanding is only possible because XPeng has the hardware to run these massive models without needing an internet connection. We cannot ignore the geopolitical reality of this achievement. For the last 20 years, the global supply chain has been a leash around the neck of the Chinese automotive industry. Every time they built a car, they had to pay a tax to America. They had to buy chips from Nvidia, Qualcomm, or Intel. This meant that their destiny was not in their own hands. A single signature on a trade sanction document in Washington, D.C. could turn off the lights for the entire industry. XPeng saw this vulnerability. They understood that true power requires sovereignty. By designing the Turing chip in-house, they have cut the cord. They are no longer dependent on Western technology. They have built a fortress. This vertical integration does two things. First, it secures their supply chain against trade wars. Second, and more importantly, it crushes the cost. XPeng can produce this level of supercomputing power for a fraction of the price that Mercedes or BMW pays to buy inferior chips from suppliers. This economic advantage is lethal. It allows them to put level 4 autonomous hardware in a car that costs less than a Volkswagen Golf. But XPeng is not just a car company anymore. They have evolved into something else. They have created an ecosystem called the AI Trinity. This consists of 3 pillars: the land, the cars, the sky, the air-out flying vehicle, and the labor, the iron humanoid robot. And here is the genius move. They all share the exact same brain. The Turing chip is the universal key. This creates a hive mind effect that no other company on Earth can match. Think about the iron robot. It is currently working in XPeng's factories. It walks on greasy floors. It handles heavy tools. It learns to balance. That physical data, the mathematics of friction and weight transfer, is uploaded to the central brain. Moments later, that knowledge is downloaded into your car. Suddenly, your car's traction control system understands how to handle a slippery road with the same delicate balance the robot learned in the factory. The flying car learns to stabilize in a violent crosswind. That data teaches the robot how to stand firm when pushed. Every machine teaches every other machine. It is a loop of infinite improvement. We are witnessing the extinction of a profession. The software engineer, the person who writes the code that connects the camera to the steering wheel, is becoming obsolete. With the Turing chip, XPeng has moved to an end-to-end model known as VLA, Vision Language Action. In the past, the software stack was a mess of different modules. One module to see the lane lines, one module to detect cars, one module to plan the path, one module to turn the wheel. It was a game of telephone. And messages got lost in the middle. VLA destroys this. There is no middleman. The camera sees the world, vision. The massive AI brain understands the context, language, and the brain sends a direct signal to the motors, action. It is a straight line. It mimics the human nervous system. This results in a driving style that feels terrifyingly organic. The robotic movements are gone. The car flows like water through traffic. It negotiates. It communicates intent through movement. It feels alive. And it is only possible because the Turing chip has the raw horsepower to sustain this illusion of life in real time. But power without control is suicide. XPeng knows that if they are going to release a 2,250 TOPS robot onto the public roads, it must be bulletproof. A single failure could destroy the company. That is why they built the independent safety island. Deep within the silicon architecture of the Turing chip, physically separated from the main AI cores, sits a dedicated watcher. This is a separate computer within the computer. Its only job is to be paranoid. It monitors the voltage. It monitors the temperature. It checks the logic of the main AI. If a cosmic ray strikes the chip, which happens more often than you think, or if the main AI begins to hallucinate, the safety island detects the anomaly within microseconds. It instantly cuts off the main brain and engages a hard-coded safety protocol to bring the vehicle to a safe stop. This meets the ASIL-D safety standards, the highest classification in the automotive world. It is a fail-safe built for the chaos of reality. We need to spend a moment on the flying car, the Aero HT. Many critics dismiss this as a gimmick. They are wrong. The flying car is the ultimate stress test for the Turing chip. Navigating in 3 dimensions is exponentially harder than navigating in 2. In the air, there are no lane lines. There are no stop signs. There is only physics and wind. By forcing the Turing chip to master the complexities of flight, XPeng is overtraining the AI. If the chip can land a vertical takeoff vehicle on a windy rooftop, parking a sedan in a supermarket car park is child's play. The data gathered from the sky trickles down to the road. The sophisticated 3D spatial awareness required for flight is being repurposed to make their cars uncrashable. While Tesla is struggling to master roundabouts, XPeng is mastering the sky. This technological arbitrage is giving them a lead that is becoming impossible to close. The integration of the iron humanoid robot is the final piece of the puzzle. XPeng is not just building cars, they are building the workforce that builds the cars. The iron robot, powered by Turing, is already deployed on the P7 Plus assembly line. It is performing tasks that require fine motor skills and complex decision-making. This is the ultimate vertical integration. The chip designs the car, the chip drives the car, and the chip builds the car. This closes the feedback loop entirely. XPeng has created a self-sustaining ecosystem where the intelligence of the product improves the intelligence of the production method. It drives down costs to levels that Western manufacturers cannot comprehend. How do you compete with a company that doesn't pay salaries to its assembly line workers? Because they are robots running on the same proprietary silicon as the product they are building. You don't. You lose. So, where does this leave us? We are standing on the precipice of a global invasion. The XPeng Turing is not a research project. It is in production. It is powering the P7 Plus. It is powering the G7 Ultra. And in 2026, XPeng is taking this technology global. They are bringing the Turing architecture to Europe, to the Middle East, to Southeast Asia, and eventually to South America. This is an ultimatum to the legacy automotive industry. To the executives in Wolfsburg, in Detroit, in Toyota City, the game has changed. You are no longer fighting a car company. You are fighting a robotic superpower. You are fighting a sovereign AI. The era of the analog car is dead. The era of the smart enough EV is dead. 2250. TOPS is the new baseline for survival. If your machine cannot think at this speed, It is just a dumb terminal on wheels, destined for the scrapyard of history. The revolution has arrived. It speaks the language of Turing, and it is coming for everything.